Thank you all for joining. This is going to be a two-part workshop on building secure interoperable healthcare apps in Flutter. My name is John Manning. With me here is Grey Faulkenberry. We're both physician informatician Flutter developers, which is a thing now, and we all greatly appreciate your time for joining us during this workshop. This is low-key, this is informal. Ask questions, interrupt. The goal for me is to help you, and so I want to try and match your all's comfort level. It is listed as an advanced Flutter talk. There's some stuff that's kind of intermediate to advanced. There will be live coding. If you want me to adjust the timing of this or answer questions as we go, I'm happy to do that as well. Really, we have 4 goals today, which are to explain what this thing called Firefly is, and if you've not actually heard of Fire, we'll define that as well, and show at least a demo of some of the existing use cases that are live in various healthcare settings, and then talk about some of the security and best practices that are there. If you want our slides, they're available. I have a QR code at the end as well. So I'll leave this up just so that you can take that if you'd like. All right, so who are we and why are we up here talking in the first place? So my name is John Manning. The MD means I am a practicing physician. Grey Faulkenberry also is a practicing physician. He has a master's in public health. The AMIA and ASAP are specialty bodies that we've spent like a decade of service on and all sorts of other elements with. They're all stories. Both of us care for adult and children. Mine, the patients that I care for are all in emergency medicine settings. I took care of adults literally earlier this week. Saturday, I'm going to take care of children. Grey is a hospitalist, so he cares for patients that are admitted to the hospital strictly in that setting. In addition to med school and all of that, we both did extra training in a thing called clinical informatics, and then Grey did global health as well, and we both live in the Southeast in different areas. So I'm CEO of MayJune, which is a healthcare software development company that exclusively uses Flutter. Grey is our CTO. I also have the title of Clinical Associate Professor at Atrium Health, and Grey is the co-chair of Global Health Informatics at Children's Hospital of Philly. CHOP, that's right. At MayJune, we focus on digital solutions where your interactions actually match the things you want to the conversation we had earlier about poor usability. That was the inspiration for this path that we've taken with our careers. And we've got a decent amount of clinical practice, multiple specialties, some informatics experience, global health, practicing in multiple countries. We have a developer expert in Flutter. We have cloud certified DevOps engineers and Fire experts as well. And Grey usually won't talk about it, but he spent a year of practice in Uganda and wrote a book on how to care for children in the hospital and low resource settings. So if you've not heard of clinical informatics, this officially is how you use data, information, and knowledge to improve health and the delivery of healthcare services. And what's the difference between data, information, knowledge? It's all that levels of basically escalation of abstraction. And this you'll see all throughout, but essentially you're just connecting the dots so that you can kind of bring more understanding to the efforts that you're doing. And this is important, like a lot of the tech that you use as a clinician or in X, Y, or Z location, the level of decision support and the level of interaction needs to match what you as the expert user have to use on during your shift or during your clinical scenarios. I like this, and I've shown this before AI became a huge thing, but you need a foundation, and essentially what we do is we allow you to be elevated further so that you can build more stuff and do more things effectively. They're all building blocks. So we're going to talk about FHIR. Has anybody heard of FHIR? F-H-I-R?
Depends on the spelling.
Depends on the spelling. Has anybody heard about F-I-R-E? Yay. So fun fact, this is me at med school prom on the left, and on the right is actually at a bachelor party, both here in New York and outside. This is like 10 years ago. But I still juggle FHIR. I'm juggling next week for emergency medicine doctors. Yeah, the F-H-I-R, I will hand this over to Gray to define and talk about in more detail.
Thanks, John. So yeah, so FHIR, what is it and why is it important? It's a data standard developed by HL7, which is a data standard body. They are aware and have approved our works, but this isn't an official endorsement by them. So again, sort of, what is it? It is a data standard. It is available with specs in JSON, which is what we use because that's what we're most comfortable with. It does also exist in XML and Turtle if you happen to use those. Some of the folks who created it really like XML. But it was initially created as a data information exchange standard. So to move data from one place to another, although more and more it's actually being used as a storage standard as well, because if you're already using and transferring your data in this format, why not just keep it there as opposed to transferring it back and forth? It also leverages modern technology. So most healthcare standards are at least 30 years old. Data standards, and if you look at some of them, they look that old. So if you look at their formatting, it looks like the sort of stuff you saw in the 90s. It's painful, it's awful, it's a lot of commas, and it's all pushed together, hard to read. FHIR tries to leverage more recent standards like JSON. It uses REST APIs. Its authentication is a version of OAuth 2. It follows the 80-20 rule, and the 80-20 rule is that it's trying to cover 80% of what you do and use in healthcare on sort of a regular basis. There is always going to be specialty services and care that doesn't really fit. And so the version before this, they tried to cover everything that will ever be covered, and it became way too cumbersome, way too detailed to actually ever be used because they tried to put everything in it. So FHIR does not do that. It tries to cover the 80% that is sort of commonly used with extensibility, so you can build in other stuff if you need to. Almost all of it's open source. Certainly all of the general spec is open source. Most of the tools out there are actually open source. It's very community supported. There's an active, really supportive community on an app called Zulip. It's kind of like Slack, but everyone's really friendly. Everybody just sort of talks and shares. And you get really quick responses. There's sort of three main guys who sort of started this whole thing. They live in different parts of the world, so you usually get one of them responding within like 12 hours if you ask anything. So again, it's a small, close-knit community, which is kind of fun. And it is international, and I think that's really important. So much of what we do is always focused on the US, which is great, and we understand, we live here, but having something that doesn't have to be in the US, that you can transfer that knowledge elsewhere, I think is important. And for stuff like health, as we saw with COVID, being able to share that data back and forth, extremely important. And so not to pick on my own institution, because we're not the only ones that have this issue, but Children's Hospital of Philadelphia, as you see, is a building that is physically very close to the University of Pennsylvania Hospital, like literally right next to each other. They both are on the same medical record system, which I won't name because I will get in trouble, I'm sure. And I won't make you answer, but does anyone know the quickest way to share records from one building, one hospital to other? Raise your hand if you think you know. I won't get you to answer, but do you think you know the answer? So, all of you who said the street, because you walked from one building to the other, you print it off and then carry it back, you are correct. Although, I would also have accepted fax, because that's the state of healthcare. I regularly get 400-page faxes of patients' medical records. Because even within the same healthcare system, even within the same electronic health record, sharing data is painful and hard and works terribly. Again, anyone who's ever gone to multiple physicians and tried to share data, you know this. And so this is a huge issue. This is painful for everyone involved. And so this is what FHIR does. This is what FHIR was made to deal with. And there is big interest, and from the top levels. This is not something, it is, again, healthcare unfortunately changes very slowly. So it's slow to adapt, but big players are involved and interested. So the ONC is sort of at the federal level, Health and Human Services, they're the ones in charge of the tech piece. So they put out stuff about Fire, and there's actually federal regulations now that say at least part of the data of your healthcare data has to be available in Fire by national regulation. And they get in trouble if they don't. NIH, CDC, all interested in it. But again, it's an international thing. So Helena, which is the informatics group that heads up Africa, they are pushing Fire. AHIN, I know the head of that, he is a big Fire advocate. I know Australia uses it, Germany, NHS, are all big into it. And then all the big tech groups all have their own Fire servers and their own Fire services that you can utilize if you happen to use that particular tech stack. So again, a lot of interest. Again, it is hard because so much of your data is locked away. It's in systems that are, again, old, bulky. All US systems were based on billing that they then added clinical care to. So they were not made to take care of patients, and they were not made initially for clinical data. And so it's really hard just to pull it out. And that's part of the reason it's hard to then use it. But we are slowly and steadily getting more and more use out of it. So again, Fire is important, it's becoming more important, and will continue to become more important. These are just some of the Fire servers that are out there. Again, all the big tech players use it. There's a number of open source ones that you can sort of run on your own if you want to play around with it. The sort of standard that most people will reference is Happy. There's actually sort of an open server online. If you want to like mess with it, you can make RESTful requests to it, push stuff to it, again, and just obviously don't send real data to it. But all these other ones are out there, and again, they're all being used. A lot of research, because when you're trying to pull data together, ends up being Fire, because that's the easiest way to put a bunch of data together. So Firefly is Fire with Flutter library integration. So this is our attempt to be able to use the Fire standard within Flutter. And again, we think it works really well. Flutter, we know, all of us here, we like Flutter. We like designing in it. And again, user interface is so important. As we just discussed, medical software has some of the worst user interfaces I have ever seen anywhere. They weren't even made by sometimes stuff is too technical for most people to use. This is too technical for humans to use. I don't know who made it, but it was not people. And so Firefly is roughly equivalent to Open Health Stack. If you're unfamiliar with Open Health Stack, if you tend to work in Java and Kotlin, and you design for Android, you're probably going to want to use Open Health Stack. This is the Google offering around Fire. They use it a lot in developing countries. The WHO actually has an initiative called Smart Guidelines, which is about clinical decision support using Fire. Again, mostly for developing countries, and Open Health Stack is sort of the standard they've been testing against. And so Firefly aims to sort of mimic that in Flutter. So again, if you prefer Java and Kotlin, you're probably going to use Open Health Stack. But if you like Flutter, like most of us do, we want you to be able to use Firefly. And so we have done our best to sort of mimic and mirror all that functionality. And so John will show you how to actually use some of these as we go through. There's some core packages, and at some point I had divided them up by sort of functionality. I've now had to divide it up by version because I broke pubdev multiple times because there was too much code. Fire is a big standard, and so putting there's DSTU2, STU3, R4, R4B, 5, and now 6. And so I had all those sort of in one package, and it was too big, and pub.dev couldn't analyze all of it. So now I've broken it down, and so you just pick the version you use, which is fine because most people most of the time are not going to use multiple versions. 4B is the one that is sort of officially endorsed by the US government at this point. 5 is the official version that is released, and then 6 is the preview of the next version. So the base package is really just serialization and deserialization. It uses freezed, if you're familiar with it. It has the from JSON to JSON, but then you can also define things specifically in Dart. And so the patient that we saw a little bit earlier, this is how you would define all those things within Dart. It looks like any other sort of Dart code. Fire at rest, again, Fire tries to do techniques and things that you're familiar with already. So this is all RESTful, but within that sort of RESTful normal CRUD requests that you can make, there's a lot of other things. There are ways to search, create, not just put, post, and patch. There's a lot of sort of other versions, and there's a lot of things you can do within it. You can actually search within a RESTful request. You can put search parameters, as part of the URL. which can get pretty long and complicated. And so this is just trying to help simplify and abstract some of that away. Fire authentication, as anyone who's done authentication, it's painful. Authentication is always painful. The Fire tends to endorse a smart on Fire authentication and authorization. Smart on Fire is really just OAuth 2 with a couple of extra parameters. So if you've ever done OAuth 2 OpenID sort of flow, this is the same thing. We just, again, tried to wrap a couple of those things like clinical scopes as well, so you don't have to think too much about it. Otherwise, it's the same flow, and we use the OAuth 2 packages that are already present in Flutter. These are some extended packages that you may or may not need. FireDB is just, we use Hive for sort of local data storage. We found that it worked the best for us. FirePath is definitely a little more complicated. It's used throughout the Fire spec. It's a path-based navigation extraction. So if you've used XML path or JSON path, that's sort of what FirePath does as well. Again, it's a little more advanced Fire stuff, but we do have a path that does it, or a package that does it. Firebulk, Fire, when it's uploading and downloading in bulk, is an ND-JSON file, and this just helps you manage some of that. A couple of the future packages, again, to sort of fully and formally mirror all that Open Health Stack does, is validation mapping, and then CQL, which is clinical quality language, which is another formatting that, again, highly uses Fire to do some things. And then the last one I've been playing with is Pocket Base. Specifically, Pocket Base is in Go, but you can run it as a Flutter app. And so again, in low resource settings where it'd be really handy to be able to run an entire backend server off of a mobile device, we've been looking into it. And so again, not fully developed yet, but in the work, because it will never be as big. And so if you're gonna actually run this here, certainly use one of the ones that's already out there. But if you need a specific use case of being able to run mostly offline or in an area where internet is not stable, or you can't always depend on the electricity, then that might be an option in the future. It is a lot of code. Like I said, this is why we broke pub.dev. We use and we generate it mostly from the Fire spec. It is a JSON spec, so we can take whatever new version and it generates sort of all the free classes automatically. So it's pretty easy to update. It only takes a couple hours each time a new version comes out. We then take all of the test cases that exist on the Fire website and run it through to make sure it serializes and deserializes properly. Again, to make sure that we want to try to support the basic spec as much as we can, because we don't want to deviate. There's normally already stuff you have to sort of change and do yourself, and so we want to try to stick to the general understanding of what Fire is as much as possible. Use cases, this is sort of where I started during my fellowship. Again, I have a big interest in global health. I work internationally. And when you look at sort of the healthcare software out there, it looks like this. There's good basic data collection, basic data sort of analysis software, stuff like RedCap or Comcare if you've ever used it, but it's just data collection. You can't do a lot with it without porting it over into something else. Then there's a lot more full EHRs, so things like Epic, Cerner, Allscripts, if you've ever heard of them. These are the software that we tend to use. These are usable. I don't always like them, but they're functional. But they're big, they're heavy. It takes a lot of work to implement it and a lot of work to support. And there's a gap there. And so if you are in a low resource setting, and that can certainly be in the US, something like Indian Health Services, public health clinics, or just anywhere where you're small and you don't have a big, robust support to put in an EHR, you're sort of SOL. And this is really where we think sort of May June fits and Firefly fits, is that gap between. And so far we've created sort of a number of apps. We've used one for social care, for referrals, for screening children, for different conditions that may need referral to housing, may have food insecurity. We have done pre-hospital care, so this is an EMS app, so it has algorithms for EMS services when they're trying to take care of patients that they pick up before the emergency room. And then we actually developed an app for the American help me out, John. College of Emergency Physicians, not mine. I don't remember it. And again, but this has their algorithms and their protocols for how they take care of people with their guidelines. The stuff on the right is proprietary, but the stuff on the left is not. All of Firefly is open source. It's all available. If you want to use it, please do. Please take a look. We welcome PRs, suggestions, recommendations. We want it to be useful. We want it to be as friendly and user-friendly as possible. This is really important. We truly believe that we need better tech in healthcare, and we want to be a part of that. And so we have tried, we've done stuff, almost all of our stuff is available in multiple languages. We've really focused on user interface. We want to try to do it right, and we want to support anyone else who wants to do that as well. We have been involved in a couple of national projects, gotten some national recognition specifically for our social cares application. We have a couple of global collaborators. I know it's being used in at least these countries for some development. It may be used in more. It has been extended. There's a specific workflow around sort of questionnaires and data gathering in Fire. And so both of the other packages that have built off of our work focus on that. And back to you.
Yep. Any questions so far as we freeze in this one? All right. All right, now it's time for some fun stuff. So what we're going to do is we are going to build, and I'll just show you the end product. This will be part of the workshop now, as well as a good part of the next workshop as well. What you see, this is open source, MIT licensed. What we're going to do is essentially make a very simple Flutter application that allows you to be able to see Fire data, allows you to be able to modify Fire data locally, and allows you to upload that data to the cloud. And we're using the happy open Fire server for this. Okay. So what I'm going to do, can you all read that text okay, or do you want me to make it larger?
A little larger.
Larger. How's that? Is that good? All right. So first things first, if you're building anything for health, you absolutely need to use a separation of a dev, a stage, and a production environment. And if you separate them in different packages, you can do that. Usually whenever I do live coding, I would do like Flutter create my Hello World app. But honestly, Very Good Ventures, their command line interface has a really good Flutter create that includes dev, stage, and prod. It includes some other, I'll just say, opportunities whenever you're building things. And it comes with block and qubits, which I'm not going to use. But I am going to use the base package and essentially get all this stuff up and running. So here, as I go through this is always way harder whenever you have half of your screen all the way up. So first things first, I'm going to get rid of, there we go. Can you see this text? Is that big enough? Okay. Yeah. So they recommend Flutter block in their code. I'm going to get rid of that. I'm going to at least start this on iOS so that you'll be able to see that. And I'm going to get rid of all the block stuff while this is loading for the first time, just because we're not going to actually use that kind of as we go. So essentially, what this package will allow you to do, let's get rid of that, is if you look in the lib folder, and I'm going to get rid of these two tests. If you look in the lib folder, you're going to have your separate dev, stage, and production environments. You'll have a bootstrap that allows you to essentially have your observers and to give you whatever logs that you need whenever there's an error. And you can update and modify this kind of to match your own needs. Usually what we do on ours is we essentially do this with, oh yeah, okay. So I'll just get rid of all this. We essentially use the Code with Andrea's recommendations that they have for like a river part architecture that's all feature based. So I'm just going to get rid of this part, add some scaffolds with an app bar.
John has done this a lot, and so he's very quick at it. So if you feel like you've missed something, or
Yeah.
feel free to ask him to like repeat something, because I watched it last night and I've seen it enough that I know what happened. But He's quick.
Yeah, so essentially what I just did, I got rid of block. I broke the app because I did that too soon. So now I got rid of all of the block stuff, and now we essentially have just a bare bones app that has, if you look here, an app that has material app, and it just says essentially at the very top, hello Flutter as a text widget, period. From here on out, I'm only using this screen. This is just the quickest way that I can get started so that you can be able to see everything. Of course, when we build them in production applications, it's going to be organized and architected differently, but this is primarily just so that you can at least see where we are. The other thing I'll say, kind of as I'm within this scaffold, and I'll start here and then I'll extract the scaffold out into its own stuff. But if I have in a body a center widget with a child that has a text right here, and just say, can you read me? Not a soul can read any of that text unless you've got like binoculars or something. So the other thing also for live coding sessions, what I like to do is I'm just going to make all of the text a large enough font that you all can be able to see that. So within theme data, I'm going to override a few variables of the text theme. There's 3 specifically. I'm going to use the body medium, and I'm going to have that as the text style with a size of, we'll just say 28. So now you can actually read that, hopefully. Yes, great. The only other 2 that we'll have for this are going to be for body large and label large.
And this is, I mean, this is important for the presentation, but remember, this is a medical app, which means you want to think about accessibility for, even more than you might otherwise. Again, if it's clinicians you're focusing on, it's a little different, but if you're thinking patients, you have to really remember that a lot of your patients may be older. They may not be able to see as well. And certainly there's lots of color blindness, other things that you need to consider with applications. And so it's really important in medical applications to really focus on that usability and accessibility.
Yep. All right. So next thing that's here that I'm actually going to do is I'm going to put this in a column just to give some placeholders for part 1, patient info. Next one is going to be the part for editing patient. And then the third is going to be for upload to cloud. And essentially, for the first part, all we're going to do is essentially this. And then we'll kind of go through we'll do a little bit of the edit patient just so you'll be able to see that part from there. And then a lot of the fun stuff is going to be kind of in that connection with the happy servers. Make sense? That's our game plan. So within here, I'll just tell you now, because if we're going to be able to store patient information, I'm not doing a state management system. We're just going to use a stateful widget. So I'm just going to extract this scaffold down into a single stateful widget just so you can see where everything is. So here, I'm going to just go ahead and do, I love shortcuts, STFUL, if you have the right extensions, make your life way easier. And then I'll call this home view. I'll paste that scaffold back in and then bring this over into here. And that should, don't save, hit save. And if I hit refresh, and if I make some changes to here, you should see that it's updating in real time, which is great. Okay. The next thing I'm going to do is just change the main axis size so that we're all kind of, so that everything is at least in a logical position. Okay, great. All right, so if we are working with the Flutter packages, the way that we originally would do this is you would import, and I'll use the command palette to add a dependency. What we used to do is you would do fire and fire auth and fire at rest. So the RESTful APIs, fire for the base, and then you would do fire auth, and then you would just import R4 for each of them. What is newer now is just using Fire R4, which has everything in one place, because if you're only going to build in the fourth version, it's going to be easier for you, and it's easier for the pub.dev analyzers to work with. So I'm going to import Fire R4. Once this finishes running in Build Runner, I'm going to create a private variable of patient that is going to be nullable.
Sorry,
Yeah.
side question. How do you use the command palette to install the thing? I've never seen that.
Command-Shift-P is your friend.
Lifesaver.
Lifesaver. This is for Mac. There's, I think it's Control-Shift-P on PC.
Do you need an extension?
Nope.
No.
For the add dependency?
No. I think it comes with Dart. I don't think you need an extension for that.
You only need Flutter.
So you just need to
Just Flutter and Dart, yeah. The other ones that I'm using, just so you know, and I can show you some of those extensions, but that's a good question. The other ones that I use for state, here, let's just search. I like better comments. Awesome Flutter snippets is how I'm doing the like STFUL, STLSS, stuff like that. I have in here, there's another one that's specific to actually setting up, like whenever you hit save, if you notice, if it could use a const, it's automatically adding that. That's in your settings.json file. And I have on my FireGene repo, I gave a live coding talk for University of Maryland, and I spent 5 or 10 minutes just covering those shortcuts. And they're all listed on that open source package too. So I'll bring that up whenever we go so that you can see those. Yeah, for sure. Anything that speeds you up, I think is always helpful. So here we are. I've imported R4. It's going to just default to that. I'm going to make this as a private variable called patient and just leave that as is. The other thing that we're going to show, if you look on our, let's see if I can show you here. The other thing that we're going to have is a patient ID. And so for that, I'm just going to, I know it's a string, and I'm just going to call it patient ID. These are both nullable. I want to be able to add and remove them. The patient ID on our application, we're not going to define it. The Happy server is going to define it, and then we'll be able to see what that changes in the app. So with this in mind, we're going to start, and we're going to just have some fun with this first part of patient information. If you've not used command period to give you these actions, that's also really useful, because let's say as a good example, and I'm just going to preemptively tell you, all of this column is great, but I'm going to want some padding in here so that everything isn't bleeding all the way to the left and right side of the application. So I'm going to set some default padding throughout everything where it's symmetric and horizontal of, we'll just start with 24. And you see the 0.0 goes away. That's where the things update whenever I hit save. Super useful. All right. So now what we're going to do, I'm going to hit command period. I'm going to wrap this with a column. We're going to have 2 versions of text so that you can see this here and here. I'm going to update this with patient ID, and we'll end up bringing in some string interpolation as well, and I'll say patient is equal to something. So if I, right here, just add in underscore patient and underscore patient ID. I'm sorry, this one is patient. This one is patient ID. It's going to give me this error that I can't have the const. So if I go all the way up here, so this is the automatic saving that I have in my JSON settings, or in my VS Code settings. If I get rid of this, it's going to find all the areas that it wants to be constant, basically constant variables, and it will just modify them all at the same time. Super useful.
Do you not like leading commas, or sorry, trailing commas?
I have them in some respects. It will just automatically format them as it wants. Yeah, so I don't always do it, but realistically, whatever looks the cleanest, I think is useful. For those that can't hear that are reviewing this later, it's the question of do we like trailing commas throughout the application? All right. Next thing I'm going to tell you, and we can either see what happens when it's broken, or I can change this later. But this patient file, so this is an interesting thing. If you look at patient specifically, and this is the benefit of having everything available in just a fully serialized object class that I can actually modify and be able to view. It will have all of the fields that are available, and it will define them all, and I'll be able to see that. And in the class, it will include all the null values for things that are not defined. But if I try to put that with patient, every single possible field imaginable is going to be listed in this text field, and it's going to bleed over everything. Whereas if I extract that into a to JSON, it'll only give me the values that I actually listed. So I can do this now, and you can see what it looks like when it's broken, but essentially I'm going to put this in brackets and move it over to JSON. Okay, so here we are. We've got part one, and now we're into this part where we need to actually put patient information that's in there, just so that you can actually see this. Yeah, I'm talking about it. I'm just going to show you this now, just so you see this. Oh. Null is not a subtype of patient. Okay, well, okay. Yeah, you're right. Okay, that's fine. Then I'll wait till later. All right, so the next thing I want to do is I want to be able to edit this patient. And so what we'll do on this is we're going to put all this stuff inside of a column. In this column, we're going to essentially have, I'm pressing Command D to modify two things at the same time. I want to have a text form field, and I want to have two of them, and essentially one of them is going to be a decoration with a input decoration that has a label of a text widget of first name, and the second one is going to be the last name. And so very quickly, here you have a spot for your first name, a spot for your last name. Great. For this, I need to be able to, in my stateful widget, have some text editing controllers and plug those into here. So I'm just going to go ahead and do that. And again, Command D, just so that I can only have to put all this stuff in once. And if you're ever working with text editing controllers and you're building them out like yourself, then you should also take the time and actually dispose everything. So again, shortcuts, make your life easier. And I'll say first name dot dispose. And this one is going to be last name dot dispose. Okay. And the last thing that I'll end up having to do is I want to have the controller here for first name and the controller here for last name. So there's a few ways that you can approach actually modifying this information. One way would be an onChanged with the text form field, where I make the modification and then have that update the patient. I can do that with first name, and I can do it with last. But if you're using a form ahead of time and you just wrap all of this with a form widget, then you can have all that logic in just once, and it's way easier. And since the logic for whatever happens when I edit the first name is going to be the same as the logic of whenever I'm editing the last name, I think it just makes the most sense. So within here, I'm going to say the first thought is if no data, then just set patient to null. So I think that makes a lot of sense rather than having a blank patient throughout everything. And then if data, update the patient value. And so what we're going to do on this part is if you're doing your checks, if you actually checked the text, like last name of the text editing controller dot text. That's what you're going to look for. But it's hard to keep everything with, I'll just say good sound null safety, because maybe first line, it was null or an empty value, and then 3 lines down, it somehow got changed and you weren't ready for that. So I'm just going to make final fields that are within this anonymous method that allow me to just have it and be done with it. So I'm just going to say final first name is equal to first name controller. Oh, I didn't actually set these two controllers. Here, let's do that.
Talking about shortcuts, F2.
Oh yeah, you're right. Hey, let's do it. Yeah, good show. F2 controller. Did I spell that correctly? I did. Great. Let's do that one. Controller. Awesome. All right. So first name is equal to first name controller dot text. Same thing for last name dot text. All right. So here we are. And then if first name dot is empty and last name dot is empty, then essentially we're going to do a set state of patient is equal to null. And that's it. That's really all we have to do for that. Okay. Next thing we're going to do, I'm sorry, we'll also return. So then we always know for a fact that there's going to be data here on out. So essentially here is where things get really interesting. And I think this is where, if you're just building stuff in REST, in your RESTful APIs, if you are trying to figure out like where is first name going to be actually within this JSON representation, it's really, really annoying. I'll just say that. And I'll just show you a little bit about this. We'll take our break, we'll finish that part, and then we'll connect it to the servers. So that's where we are just in terms of timing. So if you look here on the Fire website, and you see where it says the documentation, the resource types, you can actually find where patient is. Here's the thing, this defaults to R5. Right now, everything we're doing is in R4B. There's always gonna be variations of that. So the first thing you should do is figure out what version you are, then click on where it is, and it will tell you everything that you have, period. And if you look right here, inside patient.name, there's another thing called human name, which has different parts for first name and your last name, which are called given and family. It's complex. So if you were doing this by hand and you were making your REST APIs only for this, it's painful. Whereas if you actually have this inside of here, so I'll just say name is equal to human name, I can actually just see what is taken and be able to look through. All right, so given is actually a list because you may have multiple first names or it includes your middle name. Family is just a string. That's all we're going to have for that. Make sense? Questions so far? I think this is a really good logical point to stop writing code and go get some coffee and enjoy our breaks. I'll be here answering questions as we go. What we'll do after this is we'll have this, we'll be able to post this on the Fire server. I'll show you some elements of how you can have that and use some of the extensions within VS Code to do similar stuff with Thunder Client, and then you'll be able to search. Cool. Ha. Break time. Get some coffee. More Fire. All right. Let's get back into it. So I mentioned that you need to have this human name, and inside you need to have family and given is repeating. So essentially where we stopped was I'm going to have the new name to essentially become a human name, and it's going to save a given, which takes a list of string, and I'm only going to have this as the first name. and the family name is essentially your last name. And that's it. If I included this directly in a patient, so if I set patient to patient with name of this new name, it's going to give me an error because it's expecting a list, not a single name. So just to make my life easier, I'm gonna just wrap all of this in a list, and now everything is gonna work just fine.
Just for background on that, that's because you have different names in different places, and you can store things like nicknames, preferred names, official names, family names. And so that way, again, trying to be cognizant of people and respectful of what they want to be called is sort of, one of the reasons they built it like this.
There's another thing, just to make this code a little bit cleaner, where if, I don't want it to, if I set patient with just this value, all of the other information that's there is going to go away. So really, this is where we make use of freezed, which would be like, if I actually have a patient ahead of time, then I just want to be able to copy this with the new name and move on. And if it's not assigned, then it will just create a new patient object. And then the last thing we'll do is, so I need to put this inside of a set state, and we're pretty much done with this. So we'll just do that. We'll take these two lines, we'll move them in, and we'll see if it actually works. Oh yeah, great. So you see, this has all those null values that I was talking about. So I'm going to wrap this to JSON, and only if it's non-null. And there you go. So you have a first name that's there. I have a last name that's there, and you can see where everything actually is and what it looks like inside the patient resource. There we go. Okay, so we have this part that's set. Now, the next thing that we're going to look through is adding these types of CRUD operations. Okay, so there's two parts that I think are going to be useful. The first one is going to be creating that patient. The second one is going to be actually modifying or searching on the happy server for this patient record. By the way, I had mentioned this before that I would show, and I will share this with you after as well. But the code actions on save and the extensions, if you search for FireJune U Maryland, that has a lot of those recommendations. Yeah, of course. So if you were looking at, there's a happy fire open server that we were talking about. If you look here, the website that you would, or the URL that you would go to is http://happyfire.org and has a base R4. So this is essentially what I'm going to have, and I just want this to be a constant value. Actually, you can see this is equal to whatever that is. And if I hit save, it's going to automatically swap this over. So this is the website that I'm actually going to. Lots of people use Postman. Postman is normal for everybody. Has anybody ever used Thunder Client, just out of curiosity? Have you ever heard of it? Okay, so Thunder Client's pretty cool because you can have collections that allow you to do all of this stuff. So if I, as an example, want to set a collection of, I don't know if you can read this. I have to make this text smaller. There we go. If I set a collection where my base URL is this same happy server, I can include gets and posts and all sorts of other stuff. And here's my body would just be a patient called Jack Smith. If I hit send, it will create it and it will give me what happens if everything works as intended. And the nice thing about Thunder Client is you can include environment variables. So if you're, let's say, using the NVID package and you've already generated everything that's there, you can use that as you're pointing to these references all embedded in VS Code. So super useful. Same thing if you want to search for all the patients. I mean, these are just RESTful requests, but it'll give you a general idea of what it is that you're looking for. That create patient example, the response is going to be a meta tag of when it was last updated in version, the patient ID, and essentially a status of created. If this fails, so if I, for example, make some weird change to here and I send it, it's going to give me a resource called an operation outcome. This is for Fire, and it basically said, you broke something and this is how it's broken. So I'm expecting this to work if all I have is just a patient resource that follows what it should. So if you're doing this in JSON, you have to include the type. If I didn't include the type, it would fail. If I'm doing this here, and I'm going to create a patient, it's pretty much going to, if I'm using the Fire R4 packages, it's just going to do the work for me. So let's go ahead and make the two buttons first. We're going to call them filled buttons. We're going to have just blank on pressed, and we'll just give some to-dos here. And the child is going to be a text widget called create patient. And the second one is going to be search patients. Okay, so now we've got a create patient and a search. I actually think this looks a lot cleaner if I put these both into a column, just so that it'll all be together. There we go. So first thing I'm going to do is implement this create logic, and then we'll implement the logic to search. Since we're doing all this wonderful stuff and it's going to have network calls, you have a few ways that you can approach this. First way is being like print whatever the resources are or set whatever debugging you have. Flutter web tools or dev tools are excellent, and especially when it comes to working with this, I'm going to show you some of the recommendations that we have just to make your life a little bit easier, because all of the responses are in JSON, and it's not easy to look at some of the JSON within Flutter dev tools. So I'll just kind of show you some of that too. Okay, so let's go ahead and create a patient. So there's a couple of things of logic that I want to implement first. The first one I mentioned is I want the patient to be saved so that it doesn't get modified, so that I'm using this in my anonymous method. The second is I want to figure out if patient is equal to null, to basically say, no, this is no patient, to create, and to return, return. And so that way I know I'm always going to be creating a patient right now, every time I make this call. And then the next thing essentially is going to follow this, request, response, and show UI. Like this general logic of, I'm going to do this request first, I'm going to figure out what actually happens from there, and then I'll inform the user in some form or fashion what has happened. So first thing I'm going to do is create this request. So I'm going to say request is equal to Fire request, and I'm just going to find create. There it is. It's going to take two things. If you see here, it needs a URI, which has to be parsed from that HTTP that I listed above, this base URI. So what I'm going to do is just say URI.parse and base URI, just so I have it together and I don't accidentally misclick, however that's titled. And then the resource here is just going to be patient. And that's it. Then the response is just going to be await request.request. And then, oops, this needs to be an async. There we go. And then the last thing I want to do, you already saw that if the response was a patient, we know it succeeded. And if it is not, if it's anything else, it's failed. I don't want to include too much logic into this, but did create a patient is going to be response is patient. So if it created, I'm going to know that for sure. If it did not, then I'll have that. And while we're at it, we'll just create a little bit of a snack bar just so that you can see where everything is at the bottom. So I'm just going to make a did create a patient. Then what I want it to say is success. Great. And it's going to do whatever that response is to JSON. And if it did not create a patient, then I want it to say failure and basically give me the same information that's there. That way I can at least just see what the message was. And then if you're going to show a snack bar on an async method, essentially you need to make sure that the context is mounted. Otherwise, in the future, if you end up adding additional routes and all this other stuff, it's going to be painful for you. So I'll just say snack bar is equal to snack bar with content of text that is not const and just has that message response. And the last thing, if context is mounted, then I will get the scaffold messenger of context and show this snack bar. And then the last thing I'll say after this is going to be actually setting that patient value, this patient ID. That's the only thing that we have left to actually fill this out. And so I'm just going to do this now so we can have it all together. But same as before, I'm going to use a set state, and I'm going to say patient ID is going to be equal to, if it created a patient, then I'm going to have that as whatever that response ID is. Otherwise, I'll just have it set to null, just so that you see that everything is all broken. So let's go over to here. Let's click create a patient, and let's hope everything worked. Okay, great, it did. It gave me this 4501. There we go. And if you look in here, you can see this post with our actual request and the response. Now, in JSON, you can always click your way down through. If you're working with fire data and JSON, it gets really cumbersome to click that all. So just copy it, go back to VS Code, make a new file, and you can always just look at it this way. I find that's way cleaner. And if you have while we're at it, the pretty JSON, like JSON tools, you can minify it if you want it to be, like if there's way too much, or you can also make it look pretty. So whatever matches your needs. So yeah, we made it. We created a patient. Let's see what happens if it fails. So I guess what I'll do is I will add an extra / in this base R4. And let's just see what happens. So I'm going to click create patient. It's giving me a failure with an operation outcome. And if I look over in here, it's an error 400 bad request. So we've got both working and failed logic for here. So yay, great. Last thing we're going to do is search. And to search through patients, there's kind of 3 ways that I want to be able to set this up. So the first one is if I have information that's in first or last name or both, I want to be able to include that in my call. The second is if I have no information that's there, I just want to get a list of all patients. And really, I think that's it for search. If we looked at it in Thunder Client as an example, so if I search for patients by an ID, and I hope I remember what that other ID was. There we go. If I did this, find patients by ID, and I put this in, and I hit send, what you'll see is this is how Fire works, the REST API. It's going to give me a bundle. It's going to tell me how many values it found, and then it will actually give me the resource that's there. I think it's too much for me to just parse all of that. I'm just going to show you how to set this up. and we'll kind of work from there. But if you look, if I wanted to search by the name, it's a similar idea where I set the value for given and for family. And we'll just do, let's see if we can find this information. 23414, and we'll send it. And it found our wonderful patient. Look at that. That's so cool. So here, there's really 3 parts of this logic. Oh, and then I think the third was all patients, where that's your REST response. It's going to find a whole lot of them, and it'll just give you the first 20 is essentially what will happen. So if we go into here, same thing that we did before is equal to first name dot controller dot text. Same thing for last name. And you can make this cleaner and actually extract out the logic for this because I'm reusing my code in different parts of this application, but first name is empty and last name is empty. Then essentially what it's going to do is it's just going to search for only that, it's only going to search for all patients. I think honestly probably the cleanest way to do this, if I was putting this together and I could do a fire request and search, or I could do it the other way around, is actually just set a Boolean, bool, should search all patients, and just have it that, and then just move on with my life. And that way I'm only doing the request and response and handling all that logic later and doing it once instead of twice.
If you're curious at all about the search parameters, in the Fire spec, if you go to a resource page that's specific for patient or practitioner or observation at the bottom, they have a list of all the parameters that you can search and what sort of data it uses to search. So for names, it's going to be strings, but it may be dates. It may be codes, and again, some of this is very Spire specific, but you can search all these things and you can put them together. And so if you want, you can search for an observation that meets a certain code between these dates. And you can put that all in your URL parameters of a RESTful request, and then it will send you back that bundle, which is just a list of resources that matches those criteria.
So very specifically what we're looking for, and it will get us patient.name.family, but we're only looking for family and given as part of those search parameters. If I was doing this in my RESTful request in Thunder Client, so find patient by name, you can see it's got given and family. And if you're doing this in the R4 packages that we have, fire request search, here it is. The base is the same URI.parse of the base URI. The type that we're looking for, if you hover this over, R4 resource type is an enum that has all of the different types of resources that are there. So if I look all the way down, like contract or documents or observations, which are like vital signs, blood pressure, stuff like that, we're looking for patient. But you can see there's a whole lot of stuff that you can have in there. And then inside this request, you have the ability to add a list of string of parameters. And so this same thing, parameters, it's a non-nullable list. So I have to say if should search all patients, then it's just going to be an empty list. Otherwise, it's going to be a list of given is equal to, that's your first name, and then your family is equal to your last name. And I am missing a comma. There you go. Look at that. Wonderful. Okay, so here's our request. Great. And now we're going to follow that same general format of final response is equal to request.request. We're going to make this an await, which means this needs to be async. And I'm just going to debug print this response. Sure. Okay, I'll set a hard stop here, or I'll set a stop here, and then I will move over to this part. All right, so we already know this patient is created because we found them. So if I click search patients, we'll see what this actual response is. There we go. I don't know how well you can see this. It found an entry with a list of one thing. Again, looking through this is kind of painful. If I look actually in the code that's here, we'll see the response. And it essentially found one thing, which is here. So it is a bundle with search set as your type, found one thing, and it worked as we wanted. Great. Let's do last name Smith, and let's see how many we find. So we'll do search patients. More than 20 items. And if we look inside of here, yeah, it's found a whole bunch of patients with the last name of Smith, which is pretty cool. And then the last one that we'll do on here is, let's see if it works with 0 patients. Yep. With nothing here to see if, it should just give you a list of 20 because it's going to give you the entirety of your list. So here, my request is just patient, whereas this request was for the given and family. That's correct. And then if I resume my debugger from my breakpoint, we'll see what the response is. There we go. And yeah. So now you can see how you can actually make use of all of these search set bundles directly within your application. So again, there's so much that you can do with Fire. If you look at all of the resources, there's a lot. There's a huge amount of data that's available within your healthcare, essentially within your healthcare API. I mean, just looking at it, even at R4, each one of these goes down, and there's stories for every single one of these the data elements that you have, and there are implementation guides and ways that a lot of these interactions and workflows can come together. So even asking questions, getting responses, seeing where the status is, that's 3 different resources: questionnaire response, and a task, which kind of puts them all together. And that's just one part of the structured data capture and implementation guide and workflow. So kind of, that's a lot. We're trying to keep this at least somewhat basic where you can actually see how this can go. Authentication and authorization, you should be using Smart on Fire if it will accept it. Google has for their Google Healthcare API, it's essentially Google sign-in. So that you have to work with the different Fire servers, and they are different in terms of things they will accept, even if it's R4B. So for example, if I had multiple bundled search requests all together as a single JSON request that I'm sending to Google Fire, the Google Cloud Healthcare API as compared to Happy, one of them supports it, the other one does not. All right, so with all of that in mind and kind of thinking through, so a current use case that I'm working on through Atrium Health, through the health system that I work for, is a project to help EMTs and paramedics who are caring for patients whose hearts are undergoing massive heart attacks, get to the nearest emergency departments that are within their region. And this is an open source project. If anybody is interested, let me know. I'm happy to collaborate on this. It has some eyes from the Agency for Healthcare Research and Quality. A lot of the funding is going to be, once complete, to implement and study this in rural areas of North Carolina. Thinking about it, it's literally a map and some data, and that's it. And the patient data includes Fire as well as the EMS data standard called NMSIS. The map is the question of Are we going to use Google Maps and Routes API, which is fine if you have internet access, but if you're offline, then is it Mapbox or other elements from there? So essentially, like that's where I'm at on this. This project is pretty far along, but I'm always happy to collaborate on this. And if you want to see something that's built in collaboration in an open source space, and then see what those outcomes actually are, let me know, and we'll chat. Just so you see, this is kind of the data flow. This is if you use Maps and Routes as compared to Mapbox. And then some of that stuff requires you to actually have authentication versus others that don't necessarily require. But the data model is not that complex, but definitely includes healthcare and non-healthcare data. For all of these building blocks and things that we've shown you, I think it's really important that we have some time to at least talk about when this can go wrong. And if you are building anything that works with healthcare data, you should be aware of Alyssa Knight's funded research that she performed in 2020 and 2021, where she, as a white hat hacker, looked at 5 companies, 48 Fire apps, 5 Fire APIs, and was able to get into 4 million patient and clinician records using her portal login. She was able to use woman-in-the-middle attacks to basically bypass a lot of these other elements, and she was able to, so authentication is one thing, but authorization as well. You need to make sure you have your scopes defined. She was able to modify another patient's medication doses using her login as a portal user. Yeah. So think about that. And it's a very chilling article. If you go to Proof's website, put in your email, it's no Gmail addresses, but any other email will work. They'll give you the 50-page article, which is definitely worth reading. And some of the key take-homes from this are, I'll just say, when you think of, it's not the fire standard that is the risk. It's following security best practices and everything like that. It's not the EHR companies that are at risk. They're secure with their data. But once a patient's data leaves the EHR and gets into the hands of the patients, which per legislation from patient blocking and the 21st Century Cures Act, you as a patient have the right to your data. Once it leaves the walled garden of a health system and an EHR and is now in your hands, it is no longer covered by HIPAA, but it's still personally identifying information about you. And on the dark web, it's more valuable than oil. So this is highly sought after stuff. And if you are a Fire app developer or an aggregator of like a data lake that's pooling a lot of this information together, you may be that weakest link in the chain, which is not good for anybody. So they will come after you. Very importantly, after that was published, the response from HL7, and this was mentioned in the report, there are no vulnerabilities in the Fire standard or in the APIs from the EHRs. This was an implementation problem.
And that's something to be aware of, especially with a number of the Fire servers. It is supposed to be that as the practitioner, you can access most of the data because that makes sense. As a patient, you're only supposed to be allowed to access your own data. And so the scopes are supposed to, as scopes should, right, narrow the type of data that you're allowed access to. A lot of the Fire implementations of on the server side do not really do that. And sort of once you're authenticated, they give you whatever you ask for. And so the app, as long as it behaves, is okay, but it ends up being the app that's sort of the guardian. So if someone changes your app or gets the code and they can authenticate, they can then request any of that information. So you need to be really careful about your back end and what you're working with. And it's a hard question to figure out, and it gets much more complicated when you start thinking about family members. Adolescence is a big thing because there's some information you may share with adolescents but not their parents, or vice versa. And so it ends up being a very thorny issue, but you have to make sure you know what you're doing, who you're dealing with, and sort of not just what you're developing, but your back end as well, and what it allows.
Yeah, reproductive health as you go from state to state,
Yeah.
Behavioral health, substance use. And there are groups that are national that cover this from multiple stakeholders' perspectives, including legal, clinical, tech, patient. Shift is one of them if you're interested, pretty active with them, and happy to give you more information about that. So let's just kind of think through what you shouldn't do. Please don't hard code your API keys. Andrea Bisotto has some great Code with Andrea websites. There she talks about how to put your environment variables. Half of the Fire API mobile apps had hard-coded API keys. So it was really easy for her to just find them and work from there. If you're using anything that is even remotely close to patient data or even logging, or things along those lines, you got to have a BA with the company that you're working with. And so I think that's really important, especially for security and for ease of use. There's always going to be that balance of something that is easy for a patient, or it depends on who your user is, but I don't want to have to do 16-factor login as I'm just getting to your small Flutter application. But we need to be following these standard practices that are in place for a good reason.
And again, when you're thinking about patients, ease of use is extremely important, because most places now have patient portals, and it's something like 10 to 20% of patients actually use them. So anything that is in any way a barrier to entry, they're not going to end up using it. So it ends up not being a worthwhile venture. And so if you're dealing with a practitioner, you probably should go ahead and do two-factor authentication and the rest of the stuff we're familiar with. For patients, you have to really think, is it worth it? Do you have to do it? And is there an extra value to it? And lots of patients are not tech savvy. Lots of patients can't remember basic passwords. And so a lot of times, you end up doing a login, you send them a one-time code to their email or SMS, and then they log in with that, because you're not going to get them to use a password. It's not as secure as other ways, but if it means that they're using it, it might be worth the trade-off. And so you have to really consider some of these things, because again, access for medical apps is extremely important. And there's lots of stuff out there that as soon as you start adding too much sort of security at the level that ideally we would like, it means no one's going to use it. And so your app then is worthless. And so you have to figure out that balance, and it's a hard balance to attain.
Same thing to protect against person-in-the-middle attacks, and using reverse proxies and other ways that you can at least be able to see that your APIs aren't being used inappropriately. And even with that, limit the access to data. Don't store stuff on device if you can avoid it. Understanding we've talked about offline first scenarios, and certainly that's one of the things that we've built and looked to approach, because we like low resource settings and we try and help in areas that need it. But if it's at rest, it needs to be encrypted. So with all of that, thank you for your time. I'm happy to answer any questions you have.